Let's take a look at how you can use the normal distribution to calculate some expected results based on the probabilities that you're finding by using that area underneath that normal curve. So not only can you find probabilities under this normal curve, but then you can use those probabilities and apply them to a sample size and determine what you can expect to find. So let's take a look at how we can do that. Let's say we've got a normal distribution of SAT scores, and let's say that normal distribution has a mean or an average of 516 with a standard deviation of 130. We're going to assume that this has a normal distribution. Our question will be, if 1,000 scores are randomly selected, about how many of those 1,000 scores would you expect to be greater than 575? How in the world can we use our normal distribution curve to figure that out? Well, let's take a look and see. So let's keep our information up here handy where we can see it. Let's make it a little smaller so it doesn't get in our way. The first thing I'm always going to do, if you've watched any of my videos on this type of information, you can probably guess that the first thing I am going to do is sketch a curve. And I'm going to mark off all the information I have and all the information I want to have. So the first thing I need to mark off is my mean. And I know that my mean is in the middle, and I know that it's 516. I know that my standard deviation is 130. And I like to just jot it down up here. Even though it's already written over there, I like to write it down. About how many would you expect to be greater than 575? Well, before I can figure out how many out of the 1,000 are going to be greater than 575, I need to figure out what's the probability of being greater than 575 in the first place. So that's where the bell curve comes in. I can use that to determine what's the probability of being greater than 575. So if I can use this curve and determine what's the probability of being greater than 575, then I'm well on my way to finding out how many will be, out of the 1,000, greater than 575. So now, in order to use this bell curve, I need to get into standardized form. I need to get into units that I can use in order to use the bell curve. And those units are z-scores. So I need to convert these numbers into z. How do I do that? I use my z formula. So, for z, I use x minus the mean over the standard deviation. So that's going to be 575 minus the mean of 516 divided by my standard deviation of 130. So I'm going to have a z-score of 0.45. Whoops. So here's where we are. We're at 0.45 right here. So now I can use my positive z chart, or I can use technology. I prefer just using the chart. Generally, I'm a huge fan of technology, and I always encourage my students to use it. But for these, I just like to use the chart because it's so easy. So that's what I'm going to use. I'm going to use my positive z chart and look up a z-score of 0.45. So let's take a look at that chart. So here's our positive z-score chart. Let's look up 0.045. Here is the point 4 row, and come on over to the 5. And that tells me that my area is 0.6736. But take a look at your legend up here. That is telling me that this blue shaded area is 0.6736. And that's not what I'm interested in. Compare that to the curve that you have shaded. You're interested in this particular area right here. So in order to find that area over here in this tail, we're essentially saying we want the remaining area out of the 100%. So that's where or subtracting from 1 comes in. So we're saying 1 minus the 0.6736. And that gives us the area that we want right here, which is right here. So 1 minus 0.6736 gives us that area. Doing that calculation, I get 0.3264. So we're almost there. So our area in this tail, our probability of getting a score greater than 575, so probability of x being greater than 575, is going to be 32.64%. So we've answered part of the question, but there are two parts to this question, and we need to answer the other part. The other part to this question is if we selected 1,000 scores, about how many of those 1,000 would we expect to be greater than 575? Well, we know approximately 32.64% would be expected to be greater than 575. So now all we need to do is calculate how many scores are 32% of 1,000. So that's a simple arithmetic calculation. So let's do that arithmetic. Let's just say 1,000 times 0.3264, and that gives us approximately 326. So out of 1,000 scores, we would expect that approximately 326 to be greater than 575. And that's how you transfer the information out of just probability percentages into how many values we would expect out of a given amount.